So we're talking about a combination of epithelial tissue on the top. How many layers of epithelial tissue? 5. What are they? Well, stratified, squamous, epithelial cells. We had 5 layers in thick skin. What were they called? Bottom layer, bottom layer, stratum basal. Think about if you get stuck, think about what's starting to happen to the cells as they move up in the layers, because the names are going to describe what the cells look like. So who's next in line? Stratum spinosum, because the cells are going to start to become spiny looking. Then stratum granulosum, because what are the cells going to start looking like? You're going to start to see granules, those melanin pigments, and the keratin is going to start to mature chemically. So granulosum. Then what? Stratum lucidum, only in thick skin, right? And lucid, or there you go. When you're lucid, things are clear, and the cells are going to start to look clear in the stratum lucidum. Very good. Thank you very much. And then stratum corneum. They're going to be all, I don't know, corny. I don't know. How would you remember that one? It's the corny, horny layer. There you go. Huh? The outside layer. So that's going to slough off on corns on the outside of your feet. Very good. That's another way. I like the corny, horny layer, though, too. I'm enjoying that one. And that's also what? As far as cell number goes. The stratum corneum, that's actually the what? The thickest layer of the epithelial layers, the epidermis. And that, by then, everybody's dead. Yes? So if I was able to take a microscope and watch you walk down the hall, you know what I would see? I would see skin cells falling as you walk down the hall. Remember Pigpen? Yeah, that's what it would look like. Do you know that there are some animals that have such a strong sense of smell? They can smell those epithelial cells that you shed off your body when you walk and find you? Yeah, bloodhounds. That's how they find you. That's how they track you, you know. Dead skin cells and the organisms that enjoy eating them. Yay, dust mites. Yum, yum. So yeah, that layer that you shed is actually the way some animals can track you. So, if you don't want to be found when you break out of jail, what should you do? You can jump in the water because your skin cells would, yeah, but what if there wasn't any water available? How would you make your escape? Wear some kind of plastic enclosure covering all of your skin cells from leaving. Nobody would even notice you running down the hall in a big plastic bag, okay? So that's the way to escape from prison. So, underneath the epidermis we have what? The dermis. And the dermis has a whole bunch of goodies. Hair follicles. We're also going to find glands there. Those glands are going to produce several different substances to help protect that outer surface of skin, keep it moist so it doesn't dry out too much, and then also provide chemicals to help protect you from organisms that are outside that are kind of hostile and nasty. So we left off talking about nails. Nails is another skin derivative, or what do they call it in your textbook? It's on page 157. Appendages of the skin. We already talked about hair, right? Is hair a living thing? Part of it is. Where's the living part? That's the thing that's embedded in your skull. Those are living cells, grow very similar to, excuse me, big sneeze, pardon me, grow very similar to the epidermal layer from the bottom up. In the matrix of the hair, we find living cells, and they push their way up outside the scalp. And the hair that we see on the outside consists of dead cells at that point. Nails, same thing. They're going to start from where? Same word. What's the word? Matrix. The nail matrix is where those living cells are in the nail. So that stuff that you see on the outside is what? It's dead, just like the hair you see on the outside. So the nail matrix is where we're going to find the very similar epithelial cells. They're going to grow very, very dense and hard and are highly keratinized. That's why your nails are what? That's why your nails are harder. They're going to push through an area called the eponychium. And the eponychium is another name for what? Your cuticles. So when you look at your nails, you see a little white, sometimes. As we get older, they kind of go away. But see that little white half moon thing that's pushing out of your cuticles? And that's called a lanula. And those cells are still fairly viable. But as we push through, the body of the nail and the free edge of the nail is pretty much dead cells. What are your nails for? You're scratching yourself. Yes, that's what they're for. And doing what? Picking up things. Unless you have those big, huge, honking fake nails. And then I don't get that whole situation. Huh? They're scare-off predators. Who has the big, long, honking nails? Anybody in the class? How do you, like, button your shirt? Well, yours aren't that bad. Yours are normal.
Mine are long, but not super long.
Yeah. You know, like, what's her name? The little Long Island medium lady on the TV. Have you watched her? How does she zipper her pants? She probably has a dresser. Yeah. Good point. Good point. There you go. So, yeah. All right. I'm sorry. So that's nails. The other appendage of the skin that we see that's very important for skin and skin health is glands. One is called the sudoriferous gland. And what's that for? So, well, what's sweat for? There's a couple of things. Temperature regulation. So sweat is going to help us regulate temperature. When we sweat and liquid forms on the surface of our skin, when that liquid evaporates, what does it bring with it? This is going to visit the chemistry chapter, believe it or not. Yeah. Water has a cooling effect because it has a when it evaporates, it has it's called high heat of vaporization rate. So it's going to bring a lot of heat with it when it changes from a liquid to a gas. Exactly. So it's kind of just like kind of boiling on your skin. So what do you do to feel cooler? You stand in front of a fan. When the fan blows across that liquid, what does it do? It causes it to evaporate at a faster rate. And you can feel that evaporative cooling immediately. So that's what that breeze does for you. So that is extremely important. The other thing that we're going to find the sweat contains is waste. So there's some waste products there. There's some excess ions, sodium ions, chlorine ions. Not to be gross or anything, but have you ever tasted your sweat? It's very salty, isn't it? Your dog loves it when we sweat for some reason. Comes over and just loves to lick you, right? It's salty. Yeah, it's a weird dog thing. So we're going to get rid of excess ions. We're going to get rid of wastes in sweat. We also have chemicals in our sweat that are going to act like antibacterial agents. They're called defensins. And that sweat is going to help keep off nasty little critters on your skin. You have nasty, again, not to gross you out, but there's nasty critters all over your skin. And they're going to reproduce at quite a rapid rate. So these defensins that we find in sudoriferous sweat are going to help keep you safe from nasty little critters. Two different kinds of sweat glands. We have eccrine sweat glands and we have apocrine sweat glands. When we think eccrine, and when you look, I want to point this out because when you look at your slides in lab next week, you're going to see similar to what we see up here. Now, if you look at the sweat gland, the one I'm about to describe, basically it's like taking a hose and making a pile of tubes. Now remember, how do I make a slide? So here's my hose, big pile of tubes. How do I make a slide now of that? Can't put the whole thing in there, can I? It's too big. So I'm going to take a wedge of a big pile of tubes, right? So what do we see here? Oh, this is a, yeah, this is it. What do we see here? Cross section through the what? Through the tubes, okay? So those are sweat, eccrine sweat glands are going to be that big pile of tubes that'll lead to where? Lead to the surface. So put or deposit that sweat on the surface of the skin. Now, I always describe the other group of sweat glands as in the stinky places in our body. We also sweat there as well. Axillary, anogenital areas contain apocrine sweat glands in higher number. So those are the two different kinds of sweat glands. Then we have two other sort of modified sweat-like glands. One's called a ceruminous gland, where the secretions aren't on the liquid side, they're more on the gummy, waxy side. Where do we find those guys? Yeah, in our ear canals. That's why Q-tips is such a big organization, right? Because we constantly produce it. And it's kind of nasty when it builds up. What's it for? That tube leads to the outside, correct? There's nasty things out there, isn't there? We don't want them doing what? Crawling into our ear canal. Because what's behind our ear canal? Yeah, there's a brain back there, which is kind of important to keep safe and free of nasty organisms. We also have a whole bunch of hairs in there, which you will be more aware of as you get older, because they seem to get longer and want to leave those ear canals. So we'll start finding big long hairs coming out of your ears when you get older. Yes? Both of them are there to help keep nasty little critters out of your ear canal. Also, another modified ceruminous gland is mammary glands. In females, what do mammary glands produce? Milk. So these are secrete milk. They're secretory glands. The other type of gland we're going to find is something called a sebaceous gland. Now, sebaceous glands produce oils. And why do you think we need oils associated with the epidermal layer? Well, keratin is going to waterproof, but oil is going to help keep what? If I secrete oils out onto the surface of my skin, that's going to help keep my skin what? Moist. Also, oil is hydro what? It's hydrophobic. So it's also going to aid in waterproofing as well. One of the big reasons we see these, and many times attached to what? What is this big ball here? Hair follicles. Why do you think we have them attached to hair follicles? Anybody, you do your little hair routine in the morning, right? You wash your hair, soap, or whenever you do yours, monthly, whatever. And then some of you also use another product besides the hair soap. Can't think of the words I want today. Huh? Conditioner, right? You use shampoo and use conditioner. Why do you use conditioner? I don't use conditioner though because I have overactive sebaceous glands. It's an Italian thing. What's it for? Yeah, to help moisten those crazy horny-like cells that we see in our hair, to help sit them down so they're not all wild. When your hair gets dried out, over-dried out, what happens to it? It breaks and it cracks. So imagine if it broke and it cracked as it was trying to push its way out of that hair follicle. Would that be good? So what do you think the sebaceous glands do then? Yeah, give them a nice little lubrication so as they push their way out of the scalp, they can make it out of the scalp. So that's why we see a buildup close to here. Typically, if I didn't wash my hair for a long, long time, what would be the most oily part of my hair? The stuff that was here on the scalp, this stuff would probably be just fine. So if there was a way that we could save on soap and just wash our scalp hair, wouldn't that be something? See, that could be an invention as well. So the sebaceous gland is going to help the hair follicle or the hair push through the follicle smoothly. It's going to help waterproof a little bit. Also contains chemicals that are going to help defend from foreign substances on the surface of the skin. So when you look at your slides next week, where are you going to find the sebaceous glands? Yeah, attached to a hair follicle of some kind. They look different. They're more of that, they look more like the simple squamous epithelial cells that we looked at in lab. So find a hair follicle, and that's where your sebaceous gland is. Typically, your pseudoryphorous gland is beside them, and they look very different, that bunch of tubes that you cut through. So the two of those work together to help keep your skin moist, waterproofed, protected from any foreign invaders. And those are found in the dermal layer of the skin. Also, what else do we find in the dermis? Find a whole bunch of fibers, reticular fibers, collagen fibers, and some of you ladies have probably spent tons of and way too much money on products to help keep that connective tissue on your face nice and taut and tight as you age. Yes? What happens as you age to your connective tissue? Kind of loses its elasticity, doesn't have as many collagen fibers in it, and that's how these wonderful, way too expensive cream companies get you to buy their product, because they say that when you use this way too expensive, wonderful product, that it's going to build up the collagen in your face and you'll never have wrinkles and you'll look like you're 20 when you're 93, right? Lie. What can help build up the collagen fibers in your connective tissue better than the way too expensive creams? Two things. Diet and exercise, yeah. You know, enough vitamin C in your diet, enough of the important vitamins that are going to help produce those fibers in your connective tissue. The cream will help, but it will only help with providing the moisture that you might lose because your sebaceous gland secretions start to go down as you age. So as you get older, when I was a teenager, I could not leave the house without washing my hair because it would look like I had an oil slick on the top of my head. Yes? But now that I'm not a teenager anymore, I can get away with leaving the house without washing my hair because what's happened? Yeah, the sebaceous gland secretions start to decrease. So do the pseudoryphorous secretions as well. So Grammies and Grampies don't sweat as much as they did when they were teenagers or in their 20s. They still do smell. The apocrine gland still does exist. And just, if you think that you don't sweat in the winter, smell the armpits of your shirts. You sweat in the winter. You do. Even though it's cold outside. Again, because it's part of waste removal as well. So yeah. So, functions of the integumentary system, they help protect us from the outside environment. Remember, we have to move around in our outside environment, which can be hostile to us. Chemical barriers. Those secretions from the sudoriferous and sebaceous glands secrete or create something called our acid mantle. They tend to be more acidic in pH, and what are they going to help do? Acid. If I throw it on a bunch of bacteria, what do you think it's going to cause the bacteria to do? You explode. And they don't like that. So the acid mantle, those secretions, have antibiotic-like chemicals in them called defensins that defend us from foreign substances. It's a physical barrier, which if we penetrate, we have to start getting a little bit nervous about. Yes? Because why? Yes, we've broken into the inner sanctum. So nasty things can now do what? Get in and cause infection. Again, they discuss biological barrier as well, different chemicals, different cells that we're going to find in connective tissue are going to help protect us from foreign substances. Body temperature regulation, also very important. So the whole sweating thing is going to help regulate body temperature. Also, the dermal layer is very highly vascular. So when blood vessels dilate in the dermal layer, they move closer to what? The surface, and allow for heat exchange as well, radiant heat exchange. So that's how we help to regulate body temperature. Sensation. It helps tell us what's in our environment. Our sense of touch, being able to feel the differences in temperature in our environment are going to help us react to our environment. We're warm-blooded animals, so that if we go outside in our bikini and it's 10 degrees below zero, we know that that's probably not a good idea. Again, I never have worn a bikini even in very hot weather, so it's okay. But, you know, we don't go out in our snow parkas at 95 degrees either. So we can react to our environment properly because of our cutaneous sensation. And then, believe it or not, the skin is also going to help us with some metabolic functions as well and help to produce an active form of a vitamin D. Now, what's vitamin D? Why is that important? Yeah, it's very important in the process of absorbing calcium. And one of the big players in the formation of vitamin D is skin. So, we convert a vitamin D precursor, which is transported via blood, taking this right from the book, and converting then to vitamin D, the active form. So skin plays a big role. And what also plays a big role in this chemical reaction? Somebody said it. Sun. If you don't take any supplements, the one supplement you should take is what? Vitamin D. Vitamin D what? 3. D3. It's a teeny dinky little pill. Buy a bottle, put it on your bathroom sink, and take one every morning because you live in Maine. Did you know that? Yep. You live here. And why am I telling you you need to do that?
Winter's so long.
Yeah, winter. And yeah, what happens in the winter time? Your sun exposure dives way, especially like weeks like this. Have we even
4 days of sun.
Yeah, it's horrible. Horrible, horrible. So, if there's nothing that you take supplement-wise, take that. Because it's very helpful. It's going to help with lots of different things such as calcium absorption. Also, if you're worried about those wrinkles, vitamin D is going to help as well. So, also, believe it or not, skin is a huge blood reservoir, very highly vascular. Excretion of wastes. So skin has a big job. Some homeostatic imbalances of skin are see what happens when I drink coffee? Discussed next in the textbook. One of the most obvious things in this diagram up here is one of the scary things is something called skin cancers. So when we start to see overexposure to chemicals that might cause cells to mutate in a negative way, we start to see the development of these rogue cells on the cutaneous system. And that is what skin cancer is. That's what cancer is in general. Does everybody know what cancer is? Yeah, it's cells. Normally cells in their cell community follow very specific cell rules. For example, if I have this much space, I can only have this many cells in that space. So I can't reproduce and make more if I don't have space for more. I'm only going to reproduce and make more when I have space for them. But cancer cells don't follow that rule. So they reproduce at a very rapid rate and create way too many of them that take over the food supply that all the normal cells normally would have gotten. So what happens to the normal cells in that area? They start to die off because they don't have anything to eat. So that's one of the cell rules that cancer cells don't follow. And that can happen because of mutations when cells reproduce. We know that epithelial cells are very highly reproducible cells. They undergo mitosis at a very rapid rate on a regular basis because you're constantly losing skin, right? We have to replace that stuff. So cells that undergo mitosis at a rapid rate can have more mistakes than some other cells that may not undergo mitosis at all or undergo mitosis at a slower rate. So certain skin cancers. Now, not that anybody wants to have skin cancers, but which one would you rather have? Yeah, basal cell carcinoma accounts for nearly 80% of the cases. Not a big, huge deal if we do what? You get rid of it. 99% of cases, full excision, everybody's fine. Don't let it grow forever and ever because it's going to start to mutate and maybe turn into what? The next guy in line, squamous cell carcinoma. Rises from the keratinocytes in the stratum spinosum. And these have kind of a scaly looking finish to them. So that guy's got a big one on his nose. He's got something going on under his eye too, which is a little frightening as well. But basal cell carcinoma. You see how it's not as, it's more skin-like, it's just raised, whereas squamous cell carcinoma, the outer finish starts to be scaly almost. Oh yeah. Yeah, because when they remove those cells, they want to make sure that they have enough of a margin around those cells to make sure that they haven't spread further. So that's usually what causes the scar. Squamous cell, a little bit more invasive. Again, we can get rid of it if we surgically remove it or radiation therapy. And then the last of the nasties with respect to skin cancers is melanoma. And that's a what? That one we don't want. Which cells? Those melanocytes. And it's very highly invasive and can metastasize at a very fast rate. What's metastases? Yeah, that's when I take a trip through the lymphatic system and go set up house somewhere else. This happens at a very fast rate in melanomas. So when you start to see irregularities, and typically it's going to be something that you see in maybe a mole that you've had forever and ever, or a mole that suddenly appears and is weird, doesn't look like all the rest of the guys that you've had your whole life. They discuss things called the ABCD rule to recognize melanomas. So when you have these moles that start to change, or suddenly this dark spot appears and starts to change at a very rapid rate, that's something you want to get taken care of as soon as possible. Do people die from melanoma? Yes, they do. Do animals die from melanomas? Yes, they do. I lost my favorite dog to a melanoma. And you know where the melanoma was? It was between her toes. Yeah, very weird. So I went, and this vet, who I truly do not like now and will never like for the rest of my life, I brought the dog because there was this sore. And another thing you're going to see is it creates a sore that it just won't heal. You know, the skin can't form there normally because skin needs to form by forming a layer and then growing up. And the melanoma is not going to allow that to happen. So she had this little sore between her toes for, about a week. Brought it to the vet. The vet said, oh, here, use this cleaning solution, wrap that up. No. And he looked at it and went, oh, I think it might, just do that for a week and then come back. So naturally, it didn't heal. It came back in a week. And the vet said, oh, yeah, I think that's a melanoma. I'm like, okay. He goes, yeah, we got to remove that. But I'm going to be on vacation next week, so I'm not going to be able to remove it for the next 2 weeks. I'm like, no, we're going to remove that now. And we're going to go to a different vet and remove that now. So that's what I did. I went to a different vet, removed it right away. She was fine for a little while, until about a month later, when I looked down at her leg, and she had bumps that went all the way up her leg. So that had metastasized so quickly that it set up tumors along her whole leg. So the vet said, we can amputate her leg. And I said, let's do an x-ray because I have a funny feeling it's not just in the leg anymore. No. And sure enough, it was in her lungs as well. So I hate that vet. Nasty man. Yeah, don't you hate him too? Ugh. So it spreads very quickly, even though it doesn't look like it's a terrible thing. So it's very, very important that when you see these differences, you go and get them removed. All skin types can form melanomas, dark skin, light skin people, everyone. So when you follow these rules, asymmetry, those spots, those dark spots, I'm getting lots of them now. Some people call them age spots. I call them beauty marks. You get more of them as you get older. Huh? Yep. And some people have little areas of their skin that don't tan because they lack in melanocytes. My son has a little area on his top of his foot that never tans. And that's what it is. You just have small areas of inconsistencies in your skin. You'll get more of them as you get older. So when they start not to be symmetrical anymore, so if I cut them in half and they don't look the same on either side, go get them taken care of. So irregular borders, when they're not round on the border anymore, they start to get weird. Go to the doctors, get them taken care of. Their color should be fairly uniform. When you start to see darker spots that form within that dark area, go and get that taken care of. And when they start to get bigger. So A, B, C, D, asymmetry, border irregularity, color, and diameter are things to watch out for with anything different on your body. Different hormonal changes will cause you to form more moles. For example, when I was pregnant with my children, that's when I got a lot more moles because of some of the hormonal changes that were going on. So, the next thing they talk about in the textbook is burns, damage to that cutaneous tissue. When we evaluate burns, we look at the extent of the severity of burns using a rule of nines. So the rule of nines goes through different portions of the body, how much, what percentage of the body is burnt. First degree burn affects what? Yeah, that epithelial layer, that surface layer. This is where we get some good gross pictures in the anatomy book. Second degree burn is going to go through the epidermis and touch the beginning of the dermis. That's the one that hurts the most, yeah. What happens when you go through the dermis? Third degree burns. Yeah, you burn off many of those pain receptors that we see in the dermal layer.
So the outside of it, like third degree burns, probably hurt a lot.
Yes.
But they can't feel it.
In the center, yeah. So in order for skin to grow, it's important for the cells to touch. That's another one of the cell rules of normal cells. So when I talk about epithelial layers and them growing from the basal layer up, it's important that the cells touch. So when I get a burn or a cut or anything like that, in order for that tissue to heal, again, what do I have to do? I have to bring those layers back together so they do what? They have to touch in order for them to start to grow normally. So when we look at third degree burns, we have a big gap there in skin. What's some of the things that we could do to bring those cells back to touch? Yeah, we can skin grafting, where we actually lay layers of healthy skin in there so that the normal skin that's left can have someone to touch and grow the way it should. Yeah. Maggots is actually, I know they sound horrible and nasty, but especially when animals get wounds and things like that, maggots are very beneficial because what do? They get rid of the dead skin and they cause normal growth of those capillaries underneath, and they cause the skin to regenerate at a faster rate. So yeah, even though it sounds disgusting, maggots is actually a good thing.
Can they use cadaver skin? Because my brother, when he was like 2, he grabbed a hot coffee pot off the counter and put it down his shirt.
Poor
And
baby.
my mom picked the shirt up, all the skin came off. But they used like cadaver skin, and they had like layers, but it looked like graph paper almost.
Yeah.
Folds.
It's the way they grow it. You can actually take skin and grow it in culture, in tissue culture. And that it's because of the way it grows that it looks like that.
He's 14 now, and like,
You
all
can
his
still.
skin still looks like that.
Yeah, because just like your fingerprints, once that skin's established itself, it's got those papillary layers that are always going to grow like that. So yeah. All right, so treatment of burns can be with skin grafting, remove all the old stuff, and that's what debriding is. That's actually beneficial. Sometimes when old dead skin hangs around in those areas, it blocks the new skin from growing up properly. So when you have a wound, or has anybody ever dealt with patients that might have bed sores or things like that, or sores in the back of their head from laying down on a pillow too long? The best thing to do is to keep them clean and debrided so new skin can grow up underneath. Okay? Developmental aspects, don't worry about it. And we're done with chapter 5. Yay! Did you bring your clickers? So what's in store for us on Tuesday of next week? So exciting, an exam. An exam on what? Chapters 9, 10, and 5. What are some of the things you should know? 9, 10, and 5. But what might be in your best interest to view this weekend while you're studying for chapters 9, 10, and 5? Very good idea, interactive physiology. And maybe those 6 steps of the sliding filament theory might be something you should probably kind of know when you come to class on Tuesday. Just throwing that out there. Yes? Did everybody sign the sign-in sheet? Do you want to do some clicker questions, or do you want to bug out of here? You want to go study? All right, go study. See ya. Make sure you sign the sign-in sheet wherever it is. Make sure you bring it up. See